Hi, so this video is devoted to the first part of discussion regarding Solow model. To be more precise, the simplest version of the Solow model with the zero population growth rate and exogenous technologies. So to start with assumptions, they are as follows. So we assume that the production is described by the Cobb-Douglas production function, which, as I mentioned before, is beloved by neoclassical economists due to its nice mathematical properties. So we assume that this function exhibits constant returns to scale, and marginal product of labor and marginal product of capital are diminishing. So all the firms attempt to maximize their profit. We assume linear capital depreciation process, and here depreciation or amortization just denotes the fact that quality of physical capital decreases over time. So like old car is not the same as the new car, and again by assuming linear depreciation process, we assume that this quality diminishes according to a linear pattern. So in this version, we assume that population growth rate is equal to 0. So size of population is a constant. Savings rate is exogenous. So it's not defined by this model, it's taken as given. And there is an equilibrium on the market of goods. So saving is equal to investment. National saving is equal to investment. So the first step in the formal mathematical analysis is deriving the per capita production function. So please take a look. As I mentioned before, we will analyze Cobb-Douglas production function, and it's easy to notice that this particular function exhibits constant returns to scale because upper coefficients of capital and labor sum up to 1. So thanks to this, we know thanks to constant returns to scale, we know that dividing output by some constant is equivalent to dividing both inputs by the respective constant. And here we assume that size of the labor force is described by constant L. So we divide output by L and we divide both inputs by L. And L over L, since both of them are constant, is simply equal to 1. And 1 to any power is equal to 1. So finally, we introduce new variables, small y as per capita production, or total production divided by the stock of labor force, and small k, or capital per worker ratio, or the stock of physical capital divided by the number of workers in the labor force. And this is what we get. So this is our per capita production function. Okay, as we mentioned before, we assume that economy is closed and we have equilibrium on the market of goods. So saving is equal to investment, or investment is equal to saving, whatever you prefer. And we also assume that total saving is equal to savings rate multiplied by output. So investment is equal to saving, and saving is equal to savings rate, like some constant proportion of income not spent on consumption times national income. So I believe it's pretty intuitive, have no idea why I spent so much on explaining this. So per capita saving actually, is equivalent to per capita investment, and this is also increase in the stock of capital per capita. So small i standing for investment per capita is equal to savings rate times output per capita, or income per capita. This is equivalent. And then you just replace income per capita with the function we defined before. Ta-da! So here you have it. So for any given level of capital, you have corresponding level of output / income. So let's say for this level of capital stock, we have this value of income. And this total income can be easily decomposed to savings per capita and consumption per capita. So what is between capital access and capital accumulation per capita path is described as investment per capita, and what is between income and investment per capita is consumption. So what is remained after, some proportion of income was assigned to investment or saving, if you wish. And as I mentioned before, this line stands for the capital accumulation path. So this is simply increase in the stock of capital per capita associated with any possible value of the stock of physical capital. So on the other hand, we have capital depreciation. So this one is relatively simple to analyze. So we assumed before that depreciation of physical capital is a linear process, and we define D as capital depreciation rate. So basically delta times K will stand for the amount of capital depreciated per capita during some period of time. And yeah, slope will be equal to D. Okay, so finally we have to define equilibrium or steady state condition. So take a look. You can associate capital accumulation path with marginal benefit associated with keeping the stock of capital for firms, and capital depreciation path you can analogously say it can be described as the marginal cost. So if the stock of capital is equal to K1, then marginal benefit actually exceeds marginal cost. So if you have this stock of capital, then capital accumulation exceeds capital depreciation. And in this case, you have incentives to increase the stock of capital because each additional unit of capital gives you positive net benefit. Analogously, if the stock of capital is equal to K2, then for this stock of capital, amount of capital depreciated exceeds amount of capital accumulated. So basically it makes no sense. It's associated with economic losses, and then firms have an incentive to decrease the stock of capital. And only at this point, when marginal cost is exactly equal to marginal benefit, or capital accumulation is exactly equal to capital depreciation, firms have no incentives neither to increase nor to decrease the stock of capital. And generally speaking, equilibrium is a situation when neither of the variables of the endogenous variables is likely to change until some exogenous changes occur, changes outside the model or changes in the external environment. So in this case, indeed, we have an equilibrium because only at this point there are no incentives to change the stock of capital. So that's why we have equilibrium or steady state stock of capital at this point, when capital accumulation path intercepts capital depreciation path. So at this point, net increase in capital is equal to 0. So amount of capital accumulated is exactly equal to the amount of capital depreciated. So that's why actually we call this point steady state. So in this case, if there is no incentive to decrease or increase the stock of capital, economy will stuck at this point and we will have the same level of income. So after this point is achieved, there is no economic growth in per capita terms, and there is no economic growth in terms of gross national income, since we assume 0 increase in population size. So finally, you define equilibrium output as the function of equilibrium stock of capital. So here you have stock of capital, you go up until you reach the corresponding value of output, and here it is. So speaking formally, here you can see some algebraic solution. Oh no. So now you can see the algebraic solution to this problem. So as I mentioned before, equilibrium condition is to have amount of capital depreciated equal to the amount of capital accumulated. So in this case, net increase in the stock of capital is equal to 0, and then you just solve. So first I divide both sides of this equation by k star, and k star stands for the steady state stock of capital, and I replaced k with k star because I already introduced the equilibrium condition. So you divide both sides by k, this is what you get. Then I think I just expressed k star. Yes, so you have it as depreciation rate divided by savings rate times technological coefficient. Then you have to put both sides to the power 1 over alpha minus 1. And since alpha is less than 1 by definition, as we discussed during the first and the second workshop, then basically I can just invert it, and then I have 1 over 1 minus alpha. So this is a solution. Okay, so now this is some task for you. So this is production function, 10 times k to the power 0.5 times L to the power 0.5. We assume savings rate to be equal to 0.3. So basically this implies that out of any amount of additional income, 30% is assigned to saving. And we assume depreciation rate to be equal to 0.1 or 10%. So first you have to define the per capita production function, calculate stock of capital in steady state, calculate income in steady state, and calculate consumption in steady state. So if you'd like to practice, please put this video on hold and I will proceed with solution. Okay, so obviously we deal with function exhibiting constant returns to scale, therefore we can do the same mathematical trick and say that dividing output by some constant is equivalent to dividing inputs by the same constant, and this is what we get as the result. So hopefully you remember this. I will just mention that Y stands for per capita production and K stands for capital per worker ratio. Then to define stock of capital in steady state, you have to apply equilibrium condition. So to say that capital accumulation, like amount of capital accumulated during some period, shall be equal to the amount of capital depreciated. So then I just replace savings rate with its numerical value. The same applies to depreciation rate. And this is what I get. So I believe it's pretty trivial. You would be able to solve it on your own. So in equilibrium, in steady state, the stock of capital is equal to 900. So when it comes to output, again, here you have the function of output, and output in steady state is simply the function of the capital in steady state. So here I have it, 300. And finally, to calculate consumption per capita and saving per capita, you have to multiply income by MPC, or marginal propensity to consume, and small c is calculated as 1 minus small s. So here you have it. And when it comes to saving per capita, income times savings rate, here you have it. Obviously, they have to sum up to income. So income was 300, so consumption plus saving should give you exactly the value of income per capita. Okay, so this was it, and thank you for your attention.